Bismillahirrahmanirrahim. We come up with another June 23 5090 paper. This is the paper 4.1, which was previously called the paper 6, but now it's been called paper 4. And this is an alternative to practical. So we're going to be discussing this paper today. As you all know, this paper is for 1 hour, and you must be able to finish this in 1 hour. Now, coming to starting with the first question, now you can see this is a diagram which you need to first look at it very carefully and then study it and then understand it and then start doing the question. It says in the question, a student investigated the uptake of water by a leafy plant stem in a laboratory using the apparatus called a potometer. There's a leafy plant stem, there's a rubber bung, there's a tap, there's a scale, there's a reservoir of water, there's a capillary tube, there's a meniscus, and there's air. Now, what we need to understand is that the water is going to go up here, uh, and then it's going to go into the leaves and then out of the leaves. It's going to escape as water vapors. As water is lost from the leaves by transpiration, water is taken into the cut end of the stem. The meniscus of water in the capillary tube will then move towards the cut end of the stem. So this is going to move like this, the meniscus. At the beginning of the investigation, the student noted the position of the meniscus on the scale. This is its start position. So the start position could be somewhere here or somewhere here. The apparatus was left for 20 minutes and the position of the meniscus was noted against the scale again. This is its end position. Figure 1.2 shows the start and end position of the meniscus. Complete the column headings in table 1.1. Read the start and end positions of the meniscus on the scales in figure 1.2 and record them in table 1.1. This is 1 mark and this is for 2 marks. Now the first thing was complete the column headings. So you just have to write centimeter and centimeter here twice. Now it says position of the meniscus. Now at the start position, it was at 1.4. And you don't write the units with it, please remember. You don't write the units again and again. You just write the units in the heading once and that is for all. And then the end position, which is here, was 4.0. So 1.4 and 4.0. Now calculate the distance moved by the meniscus. Distance moved will be how much? It will be 2.6 centimeter. Or you could have written 26 millimeter. So when I put a slash here like this, it means either this or this. It doesn't mean you have to write both of them. Now it says calculate the rate of the movement of the meniscus. Now how will you calculate the rate? That's an important thing, because how much time did it take us to do this? The apparatus was left for 20 minutes. So when it says calculate the rate of movement of the meniscus, so what do you have to do? You either have to divide 2.6 centimeter by 20, and that gets you 0.13 centimeter. Or you could have said 26 divided by 20. 26 is this here. 26 divided by 20 will be 1.3 millimeter. So you see, what are the possible answers that you could have given? You could have said 0.13 centimeter per minute, or you could have said 1.3 millimeter per minute. So this was the technical thing which you had to get these 2 marks. So 0.13 or 1.3 millimeter or 0.13 centimeter. So either you say in centimeter per minute or you say in millimeter per minute. So please get this right. You must get your units right. 1 centimeter is equal to 10 millimeter. Please do not make any mistakes in this. You have to know this. This is in O levels. We learned this in class 8. So don't be so changad. Then part 5, the student had difficulty making an accurate reading of the position of the meniscus. So the person could not read the meniscus very carefully. Suggest what this difficulty was and a way of preventing this difficulty when setting up the apparatus. You see, the capillary tube is very small, the water is transparent, and the bottom of the meniscus is difficult to see. So you could use a colored card behind it, or a magnifying glass, or you could have used colored water. So in order to, you've got to now imagine if you're doing it in the lab, what would be the problems that you would face? Unless you do that, if you don't do a mental picture of it, that actually you're doing it in the lab, and why would there be difficulty in looking at the position of the meniscus? So position of the meniscus is what difficulty, and preventing the difficulty was the question. So difficulty is capillary tube is very small and the water is transparent, so it's difficult to see the bottom of the meniscus. So the possible answers I'm giving you: capillary tube very small, water transparent or difficult to see, and the prevention is use colored water, or use a colored card behind, or use a magnifying glass. Part 6. The stem was sealed in a tight fitting rubber bung so that its cut end was in the water, as shown in figure 1.1. Describe what might happen if the seal was not leak proof and the effect that could have on the results. Water can escape the potometer, and the movement of meniscus is affected. So you see, if it is not leak proof, that means water can escape the potometer, or water leaks out, or air could enter the apparatus. And so this is going to affect the movement of the meniscus, and not all the water lost from the apparatus is through the leafy shoot, it's going from the sides. And we are thinking that the water is going into the plant and then out of the leaves. So in a way that's wrong. It's not measuring the rate of water uptake. Water can escape potometer, or the water leaks out, or the air enters the apparatus. That's the description. Now the effect on the result is the movement of the meniscus is affected, and not all the water lost is through the leafy shoot. Now coming to the part 7, the tap on the reservoir of the potometer can be opened so that more water can flow into the capillary tube, moving the meniscus back to the start of the scale. The tap is then closed and the apparatus is ready to use again. Explain why the student should take several readings using the same leafy plant stem. It's something which we talk about a lot in mostly all the papers, that when you take many readings, then the results become reliable. And I'll explain this to you, how, what do I mean by reliability of the results. And the other thing we say is to remove the anomalous results and calculate the mean. Like for instance, you took the first reading, it was 6. And then again you reset the apparatus. So you made sure that the meniscus went back. So we reset the apparatus again, and then we get a reading of 9. And then we get a reading of 5. And then we get a reading of 5. And then we get a reading of say 4. So that means this is an anomalous reading, because the trend is 4, 5, 6. It should be nearly the same, because please remember, transpiration is a phenomena which is evaporation of water and then diffusion of the water vapor out of the leaf. So if you get one reading, which is, if you had just taken one reading and that reading was 9, and then you got 6 and 5 and 5 and 4, for this the first reading was anomalous. Anomalous. Please understand this English. It's not an easy English. So it was an anomalous reading. But if you had only taken one reading, then you probably have just one reading and you would. So that's why we say this a lot in A levels as well. Repeat experiment, R repeat, to make the results reliable, R reliable, and R remove anomalies. So all R's for you all to remember. because most of the Changar students cannot remember. So I make all these stories. Repeat, reliable, remove anomalies. R. Results are reliable and to calculate mean and remove anomalies. Please remember this sentence. You can write this every time. Part 8. The apparatus is designed to investigate the uptake of water by a leafy stem. Sometimes this same measurement is described as the rate of water loss from the leafy stem. Explain why the uptake of water and the rate of water loss may be different. Uptake of water and water loss will be different. Why? Because if you drink 6 glasses of water, you're not going to urinate 6 glasses of urine. The water is used in the body. Similarly, the water is used by the plant for photosynthesis. It is used by the plant for turgor pressure. The water can be stored in the leaf. The water is used for hydrolysis reactions. The water is used for a lot of it's a solvent for many ions. So it is going to be transported in the xylem and the phloem. So you see, you've got to understand is that the uptake of water and the rate of water loss may be different. Uptake of water takes in 100 ml, but all that 100 ml is not going to be passing out of the leaves. And I just gave you that example. If you have 6 glasses of water, does it mean you're going to pass out 6 glasses of urine? So that water is used by the plant. So uptake of water and the rate of water loss is different because the water is used by the plant for photosynthesis. Part B of the question, a scientist measured the rate of transpiration of a plant growing outside in a field during a morning. The results are shown in table 1.2. Time of day 4 hours, 6 hours, 8 hours, 10, 12. Rate of transpiration arbitrary units 1.1. Now always remember this first column always goes, it's the independent variable. Whenever there's a table, the independent variable comes first, and this will always go on the x-axis. So F first column of a table is always the independent variable, it goes on the x-axis. That's why the mnemonic is FIX. That's my mnemonic. And this one is always the result, so it is the dependent variable. And this is always the result which we have got out of the experiment, and this is always on the y-axis. That is why the mnemonic for this is DRY. So all we have to do is plot it. So we have only readings between 4 and 12. So you've got to spread it on the x-axis. And this is 1 and 9. So you look at the smallest figure and then you look at the largest figure. So let's start plotting it now. So when you look at it, first we need to plot the graph. And you take a scale, which is of course very convenient and which fits the whole grid. So you have to be careful how you are going to do this. And then you just plot the graph. And then you join point to point with the ruler. So if you look at it, there was nothing on 0. So we do not extrapolate. So you'll just join the points which we have. So you'll join this with the ruler. Then the next one. I might not be doing it very straight because I don't have a ruler with me at the moment. And then you connect it here. But this one will be slightly, this one I won't get a mark because it's slightly hitting it out of the. So there's one mark for plotting and there's one mark for, if you plot 5 plots correct, you get 1 mark. And the points joined with rule lines and no extrapolation. Extrapolation means that you do not extend this. You do not extend this. This would be wrong. You do not extend it. So you just join the points that are given to you. So you get a point joined with the rule lines and no extrapolation and you get a mark. So please, no extrapolation. Extrapolation means extending the graph beyond the points that were given. You can either do it on this side or you can do it on this side. But I'm sorry, we don't do it. That would be wrong. So please don't do that. Then coming to part 2 of the question, use your graph to determine the rate of transpiration At 1100, show you're working on the graph. Now you know 1100 is somewhere here. Let me use another color so that you're all clear. So this would be 1100 hours. So what you have to do is you have to show it on the show you're working on the graph. Read this. Some of you don't read this. I don't know what's wrong with you all. Some of you are just blind. I know that might sound a bit rude, but that's what you all behave like. So this is about, if you extend it here and then you extend it here, it's about 8. Whatever your graph shows, you have to realize that if you have shown this, you have to show this orange line which I've shown you, the line on the graph, that got you 1 mark, and the correct reading from the graph is 8 arbitrary units. So you realize these are 2 marks. So 1 mark is for this line that you draw on the graph, this one here. If you drew this line, 1 mark, and then of course reading from the graph is 8, you got this. Then part 3 of the question, leaves have many microscopic openings called stomata through which water evaporates and is lost from the leaf. Stomata can be open so that more water vapor is lost, or closed so that less water vapor is lost. Use this information, your graph, and the data given to explain what is happening to the stomata between 4 and 12, 400 hours and 1200 hours. Well, basically what is happening, more stomata gradually opened during the morning, number of open stomata increased during the morning. Why? Because there's light intensity and temperature and the sunlight has increased. So naturally more water would be lost. Do you understand what I'm saying? Stomata can be open so that more water is lost. Use this information and the data given to explain what is happening to the stomata between 400 hours and 1200 hours. Whereas morning time is the beginning of the day, there's more light intensity, or you can say sunlight has increased. We've offered our Fajr prayers and now it's getting morning, and there is nice light increasing. So the sun is coming out and there's more and more light, so sunlight has increased. So this of course triggers, and the number of stomata open increases, or they open more widely, or they're opening gradually. You could use all these words to explain this. Because sunlight has increased as the day has progressed from 400 hours to 1200 hours, so stomata gradually are opened during the morning. C part of the question. A student reads that the rate of transpiration is lowest when the air around a leafy plant is still. Design an investigation using the apparatus to discover whether this statement is correct. A student reads that the rate of he reads in a book or something, or he reads on the internet, or he Googles it, and he finds out that the rate of transpiration is lowest when the air around a leafy plant is still. So design an investigation to discover whether this is correct or not. So use the same leafy stem, or use the same plant. Then you use a fan, and then you can have different speeds of the fan, at least 3 speeds. 1, 2, 3. Then you measure the meniscus movement over a set period of time. You want to measure it in 20 minutes or 15 minutes or 30 minutes. So you measure the meniscus movement. We did it in 20 minutes in the last experiment. And the rest of the things, all the other variables you keep constant. The temperature should be constant, the light should be constant, the light intensity and the humidity should be controlled. And then you compare a still air with a windy results. So you have the fan, and then with the fan, and then the same plant and the same everything else without the fan. And you should see the windows are closed, so there's no breeze and no wind coming from if the windows are open. And then you compare the results and see if the student's statement is correct. Transpiration lowest when the air is still. And you need to move the meniscus back to the start of the scale, or we say this, reset the apparatus. And you repeat with the leafy stem of different plants, so that you can see, is it for all plants, is it only specifically for this plant. And then it says identify the independent variable in your investigation. So this is the one investigation which we have just done, because this is part of the C question. Remember which part of the question we're talking about. We're not talking about the previous question, we're talking about this question. So what is the independent variable in this question is the wind speed. You've changed the wind speed. That is the independent variable, is what you have changed. The movement of the meniscus is the dependent variable. A student wanted to discover whether some liquid collected from a vein in a green leaf contained glucose. Describe a test for glucose that could be carried out, included how it would show that glucose was present. So you would heat it with Benedict's reagent, and the color would change from blue to brick red. Well, that's the easiest to write because you can say brick to orange or brick red or anything that is correct. So it had 3 marks and 3 points. And of course, please specify here the temperature. The temperature could be anything between 80 degrees Celsius to 100 degrees Celsius. I always say that, though the O levels we don't expect it, but because I teach the A levels most of the time, so I want you all to know this. So heat in a boiling water bath. Add Benedict's. After adding Benedict's, then you heat in a boiling water bath, and it turns from blue color. Benedict's is blue to brick red. We've done this in a number of papers. And the independent variable would be wind speed. Speed is in brackets, we mean wind. And then let's go back to this one and see what would be the question, what would be the answer to this. So the first point is use the same plant, or you can say use the same leafy stem. If you want to say the word plant or leafy stem for the different wind conditions. And then the second point which you'd say is, okay, how are you going to change the wind condition, is use a fan. Use a fan. You can use a hair dryer, or you can place it outside, which is not very correct because the wind is going to change when you're going to place it outside. Maybe a windy day, may not be a windy day. Then you different wind speeds. You use different wind speeds. Maybe you have maybe on your fan you have a speed control 1, 2, 3, 4 or something like this, and you can use at least 3 speeds you should use. And then what do you measure? You measure the movement of the meniscus, what you just measured earlier on in the question. So you measure meniscus movement in 20 minutes. You could have said it 10 minutes also, but because we used 20 minutes in the last question, last part of the earlier in the question, so I'm using the same wording. So you could have said 10 minutes as well. That was fine. Then you keep what other variables constant? Variables constant. Which variables constant? That is temperature, light intensity, temperature. You could have said temperature. You could have said light intensity. I always like using the word intensity because there's also in A levels you'll study light wavelength as well. So temperature, light intensity, and humidity. Because you know if it becomes more humid, then transpiration decreases. Then what are you going to compare? You are going to compare what? You're going to compare still and windy results. Still air and windy results. Naturally, you got to prove something. Is that was the statement correct or not? What was the statement of the student? It said the student dread transpiration is lowest when the air is still. Is it correct or is it wrong? Or is he just, you know, he has got a very curious mind, that student, and he's thinking of all these things. So you compare still air and windy results. and then you comparison of the result with the student's statement that transpiration is lowest when air is still, right? And then you reset the apparatus. Reset the apparatus means you move the meniscus back and you repeat with different plants. Now you see something very important which I want the students to see. These are 9 marking scheme points. You want me to number them? 1, 2, 3, 4, 5, 6, 7, 8, 9. And out of these, you only have to give me 6. You hadn't to give me all these 9 points. You had to give me 6. That teaches you what? That teaches you that you write more so that you get your 6 out of 6, because maybe one of them are wrong, maybe 2 of them are wrong what you've written, and you've just written 6 points. So you write more to be sure to get your 6 points. But you need to visualize this, that you're doing this in the lab and you've been asked to study this. And you've been asked to study this. So how are you going to make a plan? So you're going to say, okay, we'll take a plant, then we use a fan, and then one without the fan, with the fan and without the fan. Then you measure the meniscus movement, then you reset the apparatus and you take 5 readings, you repeat the experiment so that the results become reliable. But because that part had come earlier in the question, so that's why we cannot write it again in this part. But usually this repeat story comes nearly in every designing and planning experiment. So please be aware of this all, and I'm sure if you do a number of papers on this, we can get understand how to do these questions. That finishes this question. Question 2 will be in the next video, and thank you very much for watching and all the very best.